Good morning, everyone.
Good morning, sir.
So first, we need to understand today about traditional network. Now, till now, whatever we have discussed, all the configuration was based on what? Traditional network. So what happens in the traditional network that we will be having different layers or different planes we have. So in the traditional network, we have one is data plane. Then we have one is control plane. And one we have is a management. Total three different planes we have. Now, what happens that whenever you are going to have any devices, let's say routers or switches, so for that, if you need to enable the communications, what is required? First, we need to assign the IP address information. We should have the MAC address information, right? So all this information, the basic information that is present on the devices individually, like IP information, MAC information, regarding the Ethernet frames, so that will be called as a data plane. Okay. So what happens? What comes under the data plane? In data plane, the information on the devices, like what? Like IP address and MAC address. Now, these are all the information that is present on the data plane, where we will be identifying the source address and destination address. With that this information, we find what? What is the source and destination address? All this information will be present in the data plane. Then you identify that, okay, my source is in one location and destination is in different location. In that case, I need to have the communications between them. And to have a communication between them, what is required here? If my devices are in different network or IP is in a different network, for that we know that routing is required. So in the control plane, it is responsible for finding the best path to reach the destination. It is responsible for finding what? The best path to reach a destination. It means that here what will come? What will be the example for this? Routing protocol. The routing protocol will be the example of this particular control plane. That can be what? Like OSPF we can use, AIGRP or BGP. All these are the examples of what? The routing protocols. The control plane is responsible for controlling the traffic, where to send, how to send. And to decide this, it is going to use what? Certain routing protocols. So first, what is required? That first in the data plane, we are going to have certain information, how to, like where to send the addresses. Then in the control plane, it decides how to send. And in the management plane, it shows you how to manage that. So we can say that this plane is responsible to manage this plane is responsible for what? To manage the device. So it is used for management purpose. And what could be the example of this? Example can be telnet. We can use this telnet to manage our device remotely. We can also use SSH to securely manage the device. We can use SNMP, right? Then we can have what? Syslog. So all this protocol will be used for management purpose, right? So management plane is responsible for managing the devices or using certain protocols, managing the devices and managing the traffic over that particular devices. So all this data plane and control plane and management plane in traditional network is individually present on all the specific devices. Like if you have, let's say for example, if I have four routers, if I have to configure OSPF on all the four routers, it means that I need to go and configure the routes on all the four routers. I have to run all the OSPF commands on all the four routers. So traditional networks require more you can say human efforts, or it requires more manual configurations. Even though we are going to use dynamic routing protocol, then the advantage is there that we don't need to specify the destination network. But the problem again, we need to at least run the command. We have to configure OSPF, AHRP like that. So is there any other options where we can automate everything? Not everything, but at least we can have a central control system through which we can control multiple devices rather than going to the individual devices. Okay. So this could be done with the help of what? Automation, and this is called as a SDN. What is SDN? Software defined networking. Software defined network. SDN architecture, we say. Correct, no? So in this, what happens that we will be having different layers. In this, data plane is called as infrastructure layer. Then we have control layer. And then we have is application layer. So same like three levels here we had in the traditional network. In the HDN also we have the three labels only. But the differences is that in the control layer, it is going to provide you what? Centralized control system. Example can be, example is controller. Like yesterday, when we were doing the wireless, so what we have done that we used to access this wireless LAN controller. It means that we were accessing multiple access point with the help of a single wireless LAN controller. And how we are going to access that? Using HTTP, right? So HTTP is what? Application layer protocol. So from the application layer, we were able to access what? Infrastructure layer with the help of what? Control layer. Correct? And that was, we were having the example as what? Wireless LAN controller. So it was providing us a platform where or a device that can be used to monitor multiple different access points. So at that time, that is also based on what this SDN architecture, right? We can say it is example. It's like that only. So in this case, what we will be having, rather than going individually to all the individual routers and configure the routing protocols, we will be having what? A controller. And from here, we can able to control multiple individual devices. Right? See now what it says. That what is automation? It refers to the use of software and tools to manage, configure, and operate the network devices with minimal human intervention. Right? What it does, it uses software and tools to manage, like for management purpose, for configuration purpose, and for operating the networking device without having manual interventions. That is done with the help of what? Central controller. So this approach, what it is advantage, reduces the human time, save time, human errors, and ensures consistency access across the network. So instead of working manually and doing all the tasks again and again, here we can have all these things done with the help of automation, right? So as discussed, we are going to have a data plane. So data plane is also called as what? Forwarding plane. So what it says that, for example, think about a routers to forward the IP packets. To forward the IP packet, it must know the IP addresses, where to send, how to send, what is the exit IP, everything. So the term data plane refers to the task that a network devices does to forward a message. Data plane is responsible for what? Forwarding a message. And this could be done with the help of what? Whether you call the data as a frame in this packet, or in a more general way, we can call it as a message also. So what it does, in other words, anything to do with receiving of the data, processing it, and forwarding that same data, this all can be done in the data plane. So here, the information and what it is doing here, responsible for forwarding and receiving of data. Data plane in traditional network. Then what are the uses in this? See, all the items in the list comes under what? Data plane. What are the list? Like adding or removing 802.1q header. The header information regarding the trunking header, the tagging that we're going to add is also example of what? This one only, data plane. Why? Because based on this only, it will be controlled that which traffic should be allowed and which VLAN should be preferred, like that. Based on this one, it is decided. That's why it is telling you that this could be the example of what? Data plane. This is important. You have to know about the examples. Then only whenever you're going to explain anyone regarding the SDN, first you have to explain the traditional network. What are the planes we have in the traditional network? And when will you explain that? So you have to tell the examples. Next one, it talk about what? Ethernet frames, where it is having what? MAC address information. And this will be required when you are going to have layer 2 switches, when the communication will happen in the same network. Then we have what? IPA packets. Then there we have to find what? Destination IP addresses. And for that, we need what? Routing, routers, and all layer 3 switches. And just we need to find here that, okay, this is my destination IP addresses. I have to send there. And to find the best path to reach that destination will not be done by the data plane. It will be done by whom? Control plane. Then even for encryption, encrypting the data or adding a new IP address, all these things is a part of what? Data plane. Changing the source or destination IP addresses for NAT translations. Okay. Let's say at present this one single IP has been mapped with the internet using a public IP. Now I want to allow a different IP also. So all addressing that we are doing to do here, it is based on data plane. Apart from this, even access control list or port security that we do is also example of what? Data plane. Because at least at last, who is going to forward the traffic? Who is responsible for doing that? Data plane only. So as it is responsible to forward and receive the traffic, so what type of traffic should be forwarded and received will be decided by whom? ACL or port security. That's why ACL and port security is also a part of what? Data plane. Right? In the control plane, what we have? it says that control plane is responsible for controlling it. So it says that refers to any action that controls the data plane. So let's once you have identified my definition, then what it says, most of these actions have to do with creating the table, and this could be done with the what IP routing table, IP addresses. So in this, it says that, see the examples, common protocol under the control plane. What are the common protocol? Routing protocol like OSPF, EIGRP, RIP, BGP, IPv4, addressing, address resolution protocols, IPv6 NDP, and STP. All these are there in what? Control plane, right? And in this, it shows that what happened, that these are the individual devices. Here we have R1, R2, and R3. So in R1, we have one control plane and individual data plane. Same as on the R2 also, we have one control plane and one data plane. Same as on the R3 also, we have one control plane and data plane. So individual devices, individual control plane. And this only will change in the case of automation. Here we will have a data plane individually present on all the devices, but this control plane will not be there on all the devices. It will be there on the central devices, right? Now, why do we prefer this management plane? That includes protocols that allows to manage the devices, like a telnet SSH. So here it tells you that once the data plane is there, where IP4 packet is present for getting forwarded. Now in the control plane, it is decided how to forward using OSPF protocol. Then in the management plane, it is decided how we can manage that, right? So for the management purpose, it is going to use certain different protocols like Telnet, SSH, SNMP, or syslog. So let's talk about that planes in the traditional network are what? Data plane, control plane, and management plane. Data plane forward the packet from one interface to the another interface. It means it is also going to identify the interface status. Control plane responsible for routing, switching, and forwarding the decision. That's why STP is also a part of what? Control plane only. Don't get confused with routing protocols or switching protocols. So here it decides how to send, how data packets should travel across the network, and this includes tasks like routing, switching, and forwarding the decisions. So all the functions that processes this using routing protocols comes under this control plane. Management plane, it handles overall network management like configuring devices, monitoring the devices, and troubleshooting. And this could be done with the help of what? Management plane, where we will be having different protocols. Clear? So all these planes in the traditional network is individually present on the individual devices. Whereas in the case of SDN, what happens? Software defined network architecture. So this new approach, it emerged in the year 2010. So approaches was that where some of the control plane functions occur. So many of these approaches move parts of the control plane work into a software that runs what? A centralized application called a controller. So we will be having a centralized devices where a centralized application will be running. That will be called as what? Controller. So a controller, or we can call SDN controller, centralizes the control of networking devices. So what it does, it performs all the functions of the control plane, just replacing the devices distributed control plane. Now, instead of having individually present all this control plane on the individual devices, what it has done, it has removed from all the individual devices, and here we have one centralized controller. And these are what? Networking devices, right? Now, if you will see here, that here we have infrastructure. Okay, and this I have written like this. See here only. That at the top, we will be having what? Application layer. At top, we have what? Application layer. Then we have what? Controller, or we can say control layer, and infrastructure layer. So infrastructure is equivalent to what? That data plane and application that will be used to access the control layer. Okay. Now, to have a communication between the infrastructure to the control layer, it is told as it is southbound APIs. And to have the communication between application layer and control layer, this is called as northbound APIs. Why northbound and southbound? See, as you know that this side we have is north, that side we have south. So you can consider here that this is the application layer, and here we have control, and here we have data or infrastructure. That's why it's if the communication is between data plane and control, then it is southbound API, and between them it is a northbound API. What is API? API stands for application programming interface. It enables the communications between different applications, application programming interfaces. So here it says that in a controller-based network architecture, what happens? The controller needs to communicate networking devices, and this is done with the help of what? Southbound API. Now, an API is like a one application program to exchange data with another application, right? So a controller northbound interfaces opens the controller so that its data and functions can be used with other program also. Now, to have the communications between the central controller and to the data plane, this will be called as what? Northbound APIs. Northbound interface. That interface it is talking. And direction of the communication will be what? Northbound. And here the southbound, like that. Clear till here? Now, what happens that whenever we have the communications using application programming interface, so it is telling you that we have one concept called as a REST-based API. What is REST? Representational state transfer. It describes a type of API, and it allows the applications on a different host to send the messages using what? HTTP. So in this case, HTTP message to transfer data over the application programming interface. And this is done with the help of what? One concept that is called as a GET request to a particular URI, unique like resource locator or identifier, we can say. And the HTTP GET is like any other HTTP GET. And then we will be having GET at a step 2, the controller sends back an HTTP GET response message with the object with most REST-based APIs. And when you are getting any information from there, that particular information will be either in the form of JSON or it will be in the form of XML. Now, if it is in the form of JSON, what does it mean? Java script object notation. This is a one language. And XML is what? Extensible markup language. So, for example, let's say you are trying to visit a particular website, or you are going to collect the information regarding the weather forecast. So when you will collect, so what is happening? You will be visiting there with the help of what? HTTP. Now, when you visit there with the help of HTTP, and when you collect the information you get with the help of is what? Application programming interface. And the information that you are getting, it will be in the form of what? JSON. But we get the information not in the JSON file. It is converted and we get into the normal text file, right? So in this case, if you will see how does this JSON file looks like? This one. So it is going to be in the curly brackets. We will be having here commas, everything. And where we don't find any commas, like here we have no commas, it means this is the end of that particular sentence or line. So JSON file will be like this, where we will be having the curly brackets. And same as we will be having like XML. So most preferred one is going to be what? JSON files. One is XML and one is YAML, Iant Markup Language. So it's like JSON file is also human readable only. It can be easy to read, but here it requires more different things like a curly brackets and commas, everything. Okay, so it is telling you how the devices is going to communicate, and it is telling you how we are going to access the controller with the help of application layer. So as we have done in the case of wireless also, that we were able to access that wireless LAN controller using HTTP. So in the background, it sends messages like get request, now get response like that. And based on that, what APIs will take place. That will have the communications between them. So this is what about software defined network architecture. Here we have is a forwarding plane, forwarding layer that is called as what data plane. These all are will be the networking devices. Then what we have control layer that is called as what SDN controller, a centralized devices. And here we have what application layer where we will be using this with help of what application. Okay. So in this, it is talking about the SDN architecture where we have data, control, and application plane. So data plane also known as what? Here also same thing. Forwarding plane responsible for actually forwarding the data packets. So it is going to carry what instructions given by the control plane, where to forward, how to forward. Fine. So it includes what all the hardware components like routers, switches that needs to physically move the data from one point to another point. In the control plane, it is responsible for making the decision how to send, where to send. And in this plane is centralized and managed by whom? SDN controller, which dictates the forwarding behavior of the data plane, how data plane should be sent. And then finally, what we have application. So this plane consists of what? Application and services that is going to interact with what? Controller and to define network policies and behaviors. And these applications can request network resources, optimize the traffic flow, and enforce what security policies and more. It means that we will be accessing this control plane through this application layer, and we can do certain changes over there. We can create certain policies or all these things. Northbound APIs. Northbound APIs are interfaces that allows the communications between what? The SDN controller and a application services running on top for it. Then southbound, that is going to have allows the communications between what? SDN and networking devices. And what is API? Application Programming Interface. It is a set of rules or tools that allows different applications to communicate with each other. Fine. So JSON, like a JavaScript object notation, it is a human readable and easy to write, and for machines also to easy to resolve and generate. So it is most widely used to transmit data between a server and a web application or between different parts of system. So same thing, it is explaining you that if you want to get the weather service provides data in what form? JSON format. And your application sends a request to a weather services APIs. It collects the information. Then your application resolves the JSON data and displays the weather information to the users. So it gets in what form? JSON format. And it changes that and it displays the client users. right? So in traditional network, it is called as forwarding plane, responsible for processing, receiving, forwarding the data. Examples are MAC addresses, IP addresses, tagging, access list, port security. Control plane, responsible for what? Control the data plane and identify how to send data from one source to the destination network. Examples are like routing protocols, even the switching protocols. Management, for management purpose, like Telnet SSH. So software-defined network architecture, in this control plane is centralized, whereas in traditional network, control plane was distributed. So it centralizes the control of networking devices. Here we have application layer used to access the control plane. Control plane centralized devices that is used to control the individual devices, make changes on the devices from where? Centralized controller. And then we have data plane that is responsible for, and it is like the same in the traditional network to forward the traffic. Now, what is the advantage we're going to have for the SDN, and what were the issues or disadvantages in the case of traditional network? So what is the advantage? Ease of network administration, right? Second advantage, quick provisioning of network. Like quickly, what we can do, we can set up all the network things. Instead of going individually to the devices, doing the configuration for the routing, we can do this with the help of what? Controller. That's why it's going to show you quick provisioning. Now it promotes scalability also. Means how we can have large more numbers of devices. We can perform the changes over the more numbers of devices at one single time rather than going individually. That's why it promotes scalability and even it enhances security because everything is there under the single control. That's why. It reduces what? Hardware cost, reduces operating cost, and this is also like a cloud ready infrastructure where we will be having all these things with the help of cloud services. And what was the issues with the traditional network? Availability issues, whether my connectivity is available or not, devices are working or not. Latency, it means delay was there. It is used to take time for the configuration purpose. Cost, high cost was there to have all the connectivity between the individual devices. Then it requires for all manual configurations. Deployment issues, how to deploy, how to connect everything. A scalability issue, we were not able to perform this on the more numbers of devices, covering a very large area, vast area, and each device need to be configured individually at control plane in the case of traditional network. So now whatever we have studied till now, so all this was a part of what? Traditional network. So what are the examples of the SDN, software defined networking? What are the examples for that? One is SD-WAN and one is SD-Access. SD-Access is based on what? Network automation. It is used in LAN, that is local area network. Then we have is SD-WAN. It is used in WAN, that is wide area network. So when you have to enable the communications between different branches, in that case, SD-WAN will be preferred. Clear till here? Got the idea of how the structure of SDN is working? Now we have radius. So what do you mean by the term radius? So radius is remote authentication dial in user services. What it does, it encrypts password. It is a multi-vendor supported. It means this can be used with other vendors also. Commonly used for the authentication to access the network. See, the difference between Tetax Plus and Radius, they both are used for authentication. Okay, for providing the authentication, who can access this? Radius is open standard, will be used to check the authentication criteria when you are going to access the network. Like example is Wi-Fi network, VPN network. If you're going to access that networks, so what is your authentication? That will be done with the help of what? Radius. Okay. This also provides you what? Remote access for the users. This is for which users? Remote users who is not going to be locally present there, right? Then we have TechAx Plus. This is what? This is Terminal Access Controller Access Control System Plus. It encrypts entire payload. It means that in the case of TechAx Plus, entire data will be encrypted. In the case of Radius, only password will be encrypted. Okay, not on this point that in Radius, only password is encrypted. In TechAx Plus, entire payload is encrypted. Second point, that Radius is preferred to check the authentication to access the network. Why do we prefer this Radius? Radius is for what? It provides you remote authentication to access the network. Like what? Like example is Wi-Fi network or VPN network. This is used for what? Remote users. In this, encrypt only password. So it is going to encrypt only password. It is going to be used for what? Multi-vendors. Then what we have? The CAX plus. Now, what is this TACAX plus? Same concept, terminal access controller, access control system plus. Now, this is a Cisco feature. First thing. So this is going to be Cisco proprietary, or you can say applicable with the Cisco devices. Now, here what happens? that it is going to be commonly used for device admin access control when an engineer logs into a Cisco router. In this, it means that here it is going to use remote authentication to access the devices, not the network. Radius was to access the network. Attacks plus remote authentication to access what? Devices. Difference. Difference. Both provides you what? Remote authentication only, but one is for network, one is for devices. And here what it does, in this, it encrypts entire payload. That is what? Entire data. Clear? Then what we have? Ansible and Terraform. So like Ansible is also like a IT automation tool, and it was developed by who? Red Hat. So it is going to, what it does, see, first thing that in this case, this is used for configuration management. Like, that, let's say, for example, you are going to have certain configuration, and that configuration need to be done on all the devices. Let's say I'm having so many servers. I need to configure all the servers. So what is the option I have? Go individually to all the servers, do the configuration, but it is what time consuming. I want what automation tools. So for that, what I can use here, Ansible. So rather than going individually to the individual devices, we will be having a script. In that script, what we're going to do, we will be writing the script, we will be writing the configurations, and based on this Ansible tool, IT automation tool, we can have or we can target all these configurations to all the different devices. So this is used for what? Configuration management. And in this, what is being preferred? See, it uses YML, Iant Markup Language. This is the language it is going to support. And this is called as what? Playbook. All the configuration that will be called as what? Playbook, which is human readable. This is used for configuration the management. You control all the target machines from a central node, and Ansible is agentless. It does not require any agent, does not require any agent. It does not have any connectivity with agent. So that's why it is agentless. It is an open source IT automation tool. Okay. So what we can write it here, Ansible is automation tool that is used for configuration management. It uses YAML language, right? And the configuration file will be called as playbook, and it is agentless. So where we can prefer this Ansible automation tool if we want to give a configuration files to multiple different servers, then there we prefer this Ansible. One more we have that is called as what? Terraform. It is also an automation solution only, automation tool. But this will not be used for the configuration management. Why do we use this Terraform? This is like an infrastructure management. Where do we prefer this Terraform? In the case of cloud. So it helps to provision your infrastructure across multiple providers like AWS, Azure, GCP, etc. It uses what? HCL language, that is called as HashiCorp configuration language. Okay. Changes are made by recreating or modifying the resources in a structured way. And this is for the infrastructure management on the configuration management. Infrastructure management means here we are not going to provide you configuration, but we are going to manage the devices, infrastructure. Okay. So Terraform is used for infrastructure management. It uses SCL language, that is HashiCorp. You can search about these two types of languages. You can check what is the format of this language. Okay. So where do we prefer this? That this will be preferred in the case of cloud. So what it does, IT automation engineer that automates the provisioning, configuration management, application deployment, orchestrations, and many other IT processes. It is free to use. How Ansible works, we can check all those things. So these are the documentation also. It is available on the Ansible website. Read this if you're interested. How to create a playbook, introduction to Ansible, start automating with Ansible, right? So it will explain you what are the things, what is required, why do we need this, everything. Why it says that it is agentless, the infrastructure architecture, because low maintenance overhead by avoiding the installations of additional software across the IT infrastructure. Means it does not require to install any software on other devices. That's why it is called as agentless. If anything, like if you want to run certain thing, and for that you need to install a software to run that on a particular device, then it is based on certain agent, right? But in this, it does not happen like that. That's why it is called as agentless. Automation playbook uses a straightforward YAML syntax for code that reads documentation. And Ansible is also what decentralized, using SSH with existing operating system credentials to access or to remote machines. We can access this using SSH also, remotely also. We can put that playbook using what? This one, SSH. Then scalability, and we can say it is predictable, easy. So easily and quickly scale the system. You automate through a modular design, supports a large range of operating system, cloud platforms, and network devices. Right? So you can go through this. What is the installation guide? Everything you can come to know about this. Right? You please visit this website, read all these things. This will be interesting for you. All the basic concept it says. See, even it shows here what? Network debug and troubleshooting guides. What is the playbook, issues, timeout, everything. Clear? Like this, you can search about the Terraform as well. Fine. So these all things are used for what? For automation purpose. Rather than going and configuring individual devices, managing individual devices, we can have this automation tools. The same thing I have written here also, that it is an open standard used to remotely access the network based on a user-based authentication. In this, password is encrypted. It is used to access Wi-Fi network or VPN. Declaratively is a Cisco feature commonly used for device admin. Based on this, it defines access control mechanism for the users, what type of configuration can be done by the users on the devices, and it encrypts entire payload. And in Ansible, we have written that it is an open source tool that is used for configuration management. Targets are what? Targets are configured from a central node developed by Red Hat, and it uses YAML. Terraform is an open source tool developed by whom? HashiCorp. It is used for infrastructure management. It helps to provision infrastructure across multiple providers, and it uses SCL language. Now, why I'm telling you that this is going to be preferred in the case of cloud? Because in cloud, what you do? You create an infrastructure, no? That I will be having, let's say, there's one term in Amazon Web Services, S3 bucket. So we need to create a bucket that is a what infrastructure that there we will be having a space for storage purpose. So what is that virtual bucket I am creating? So that is called an infrastructure. So if I wanted to have this on all the other different devices, for that I may use here what Terraform. And in that case, you have to know about all these languages, YML, HashiCorp. Okay. So we need to have a file for that, ready file. So we will be writing in all this format. Just copy and paste. Okay, you will come to know all these things when you will start in that particular specific courses. Understood the use case of radius attacks plus Ansible Terraform. Okay. So same as we have like SD access is also a different course. SD WAN is also a different course. So nowadays most preferred these are, if you want to learn about network automation, you have to go through this SD WAN or SD access. Now we have certain thing called as a network architecture. So how the devices has been connected and located in a network, here that we will be discussing. So one is telling you that if here we have two-tier campus design, it means this is a two-tier architecture. The name only suggests that this is a two-layer. So in this, what is happening here, that if you will see, here we are going to have, it is telling you we have 1,000 PCs. So all these PCs are connected with switches, right? So when we have multiple PCs connected with a switch, that switches will be called as what? Access layer switches. So what are the access layer switches? That is going to connect the end devices. Now, this access layer switches will be further connected to one more switches. Now, what is the requirement to have that? Now, see, as we were having so many end devices, to connect them, we require switches. Now, I wanted to have the communications between all the switches. So, if I will be connecting like one by one, that is not going to provide me the stable connectivity, right? So, we need to have so many devices. So, better to go with what? One more architecture where we will be having a centralized layer communication. And even this is going to provide you what? Backup also. If you will observe, here we have the communication like this, and even it is going to have a communication like this. So if at any point of time, if any one of the switches is failing, it will shift the traffic, right? So whenever the switch is going to connect to the end devices, will be called as what? Access layer. And further, if you have more switches, that is going to connect to the access switches, will be called as what? Distribution layer. And then outside this, we have routers to reach the wide area network. So two-tier campus design will be preferred in the smaller network, we can say. Here we have only access layer switches and distribution layer switches. So it says here that access layer switches, what it does, it connects to the end users. What it provide you that switches normally send traffic to and from where end users. So that's why we say that it sits at the edge of the LAN. Then distribution switches, what it provides, a backup, or we can say redundant traffic, which access the switches can be, that is going to be responsible for what? To forward the traffic to each other. That's why here it says that typically two distribution switches for redundancy purpose. And the distribution switches provide the services to forward the traffic to other parts of the LAN. And then further, this distribution switches has the connectivity with what? Routers to reach wide area network WAN. Same as we have one more three-tier architecture, or we call it as a three-tier campus design. In this case, what happens that instead of having a distribution layer, we're going to have one more layer that is called as a code layer. So what are the architecture? First, we will be having access, then we have distribution, and then we have as a core. So in this case, access is again the same thing, responsible for what? Connecting the devices. If you will see here, A11, 12, 13, 14, all these are what? Access layer switches. So here what will be connected this side? End devices. So this all side we will be having end devices connected. And then it is going to have a connectivity with what? Distribution. Here also distribution, here also distribution. Now, where it is going to be preferred? Very large network. That's why building one, building two, building three. So here it requires what? One more switches that could connect two different buildings. So this is code layer, then this is distribution layer, and this is access layer. So this is called as a three-tier architecture. And this is preferred in the larger network. What it says, access point connectivity to the end users. Distribution provides an aggregation point for all access switches. providing a connectivity to the rest of the devices in the LAN, responsible for forwarding the frames between the switches, but it is not going to connect end devices directly. Which one? Distribution. Then code layer, it further aggregate the distribution layer switches in a very large campus LAN, providing a very high forwarding rate for the large volume of traffic due to the size of the network. So in 2-tier, we will be having only distribution layer, access layer. In 3-tier, we have access layer, distribution layer, and the core layer, right? So they both are preferred in the office environment, right? In the large network environment. Then we have one term that is called as a small office, home office, or in short, we call it a SOHO architecture. Small office, home office. So in this, what is going to happen that here we have certain end devices. This is connected to what? Access point. Using what connectivity? Wireless. Then this access point has a further connectivity what? Switch. Here we have UTP, that is unshielded twisted pair cable. Then this particular switch has a further connectivity with router. This is what? Firewall. This is what? Modem. And then you are able to reach ISP internet. Right now? Now, what do you mean by this term modem? What it does? Modem is where MU means modulator. Sorry, TEM, no? And where DEM stands for demodulator. What is the function of modulator? Converts. What it does? Converts analog signal into
Digital signal.
digital signal. Whereas demodulator, what it does? It converts digital signal into analog signal. So digital signal will be in the form of zeros and one, whereas analog signal will be at any like discrete form with any number, any ranges. Then this digital signal will be in discrete form like 0 and 1s. Analog signal will be like a wave like a structure. Okay. So when the signal coming from the ISP side, it is in the analog, but our end devices understand digital. That's why it need to get converted. That's why we had a model. Same as whenever you are going to return the traffic, so you will be having digital signals and you have to send it to the ISP side. You need to convert this to the analog signal. That's why we have a modem that is responsible for modulator and demodulator, converting the signals. So in this case, here we have modem, then we have here what? ISP. So SOHO architecture will be preferred where? In the small office, name only suggest, or home office. So if in our home environment, if we are going to have a Wi-Fi connectivity, so it is based on what? SOHO architecture. Then we have spine leaf architecture. Where we prefer this spine leaf architecture? This is preferred in the data center. So in the data center, what happens that these are what leaf switches. These are the switches only. Leaf switches where multiple servers are connected, not end devices. Multiple servers are connected. Okay. Now here multiple servers are connected and these are what spine switches. And it is going to have interconnectivity with all other switches like a mesh topology. Have you seen that? Same like that. Why it does this like this? Because you know that all these servers need to be accessed by users every time. So we need here more accessibility to the server. That's why if at any point of time, if one link is not working, then I should have a backup for that. In that case, that's why it is going to have internal connectivity with all other switches. This is called a spine leaf architecture. This is also a switch only. This is a spine switches. This is called the leaf switches. Preferred in the case of data center. Okay. In general, in the case of layer 3, we can have a means in the case of a spine switches, we can have what layer 3 switches. Right now. And at last we have this is regarding the cellular network, where we have end devices connected with a cell tower. This one is having connected with the router, provider, internet. Right now. And here, this type of topology is called as hub and spoke topology. Hub and spoke topology, where we have hub is what? This is a centralized device. Or we can say this hub and spoke topology is preferred in the case of branch and head office. If you have any connectivity between them like this, so this is will be referred to as a hub and spoke topology. When you will come to this CCNP routing, there we have this discussion regarding the hub and spoke topology. Okay. There we will be doing the routing based on this. In the case of EIGRP, we'll prefer this. We'll discuss this in case of EIGRP. Okay. That's why here it is E root and E leaps. Got the architecture? So these are the architecture we have discussed: 2-tier, 3-tier, small office, home office, then spine leaf and cellular network and hub and spoke. Last topic, that is AI. Now, before starting with AI, you have to let me know what do you mean by this term AI? Because you are surrounded by AI every time, that's why. What it does? Huh? It mimics human behavior. So it says that AI refers to the ability of machine. This is the ability of the machine. What it does to think like a human, right? To do the task like human. So aim of the AI is to mimic the human brain architecture, right? No? So we will be having different roles. Under the AI, we have certain subset. Under that, we have one subset that is called as what? Machine learning. What it does? What it does? Machine learning. In the machine learning, that particular devices will be learning from the external environment. Here, it is getting or it is learning from where? From the external environment. That's why it is telling you that this is a subset of AI and What it does, see, in this machine uses to learn from the external environment, and based on that learning, it is going to responsible for creating a new algorithm. So it learns from the external environment, creates a new algorithm. What could be the examples for this? Examples can be like fraud detection, recommendation system. How? Like, for example, recommendation system, like, for example, you're watching, you're having Netflix subscriptions. When you watch different types, categories of the movies, same type of categories you will be getting always, right? How it happens? Based on the user's interest, recommendation system, because of the external users, what you are doing, right? So that's why based on this, it is going to identify that you are going to be more interested in towards these types of things, this type of contents. So it gives you always these types of content most of the time. Fraud detection, if it has happened, how it is happening. So based on the external environment that has already that is happening in the environment. So that is will be called as what? Machine learning, right? Even we have one more that is called as what? Deep learning. So deep learning is what? Is a subset of what? Machine learning. Deep learning is a subset of machine learning. Now, in this, what it does, it is based on the neural networks. How our human brain architecture works, it works on that concept only, right? So, in this deep learning, what could be the example of deep learning? Like we can say here that for recognition system, like we can have face unlock, okay? Or see, it is telling you that here we have, yes, image recognition, language processing systems. So where it has to recognize the image, in that case, it is using word deep learning, where it is based on what? Neural network that is going to mimic the human brain architectures. Okay. How our human brain works, same as this deep learning concepts works. Predictive AI, it means what? The name only suggests it is going to predict. Prediction. So that prediction will be based on what? Historical events. So if something has occurred in the past, it is based on the historical events. If something has occurred in the past, that thing is going to have certain effects in the future, and maybe this could be repeated again. So this is going to give you the historical event information, right? So what could be the example for this? Weather forecast. So it is going to give you the information based on what? Whatever has occurred on in the past, right? Apart from that, market analysis is based on what? Prediction. So we know that here the prediction is not going to be 100% correct. That's why what are the concerns for this? Concerns are for the quality of the information that we will be getting here. Then what is a concern? Accuracy, right? Integrity, reliability. We cannot depend upon, no? It is going to predict prediction. So prediction is not always 100% correct. It might be correct, it might be wrong also. So market analysis, if any weather forecast, all these things are the example of what? Prediction. So this is based on what? Predictive AI. Fine. One more, generative AI. So it is responsible for what? Creating new content based on existing content. Create a new content based on the existing content. Now, when we were not having ChatGPT, when you used to search, what you do? You search on the Google. So when we search on the Google, what happens that we used to get different links. Okay, you have to open this link, read the content, open this link, read the content, do the comparison, right? Now, when we had the ChatGPT, what it is doing, combining all this content and reflecting you a single content. So it means that it is going to find all the existing content and reflect you in a summarized format. And when you will be using ChatGPT, sometime whenever you will search, so it will show you also that this information I have collected from this websites. Okay. So what is it is doing? It is creating a new content based on what the existing content. So examples are like ChatGPT, correct? Microsoft Copilot, Perplexity, Gemini, DeepSeek, huh? And Meta. So many we have. Grok, that is for X, no? Like Twitter. Grok, Perplexity. So these are the different, you can say AI platform that is being used for creating a text, images, videos, contents, all these things based on what? Existing content. Right? No? So what are the subsets we have? One is machine learning. So machine learning is responsible or it is based on the external environment. Then what we have? Deep learning. It is based on what? Human brain architecture. Then predictive AI. That is based on what? Prediction. Or we can say historical events. Collect the information from where? From the historical events. And finally, one more we have, that is generative AI. That is going to generate the new content based on what? Existing contents. Clear? Now tell me, what are the challenges you find in the AI? Like, you know the advantage, I think. What are the challenges? Accuracy. Hmm? How it can be used. So like we can have, like, have you heard the term deep fake, all these things, right? Then privacy concerns, then over dependency of the on the particular AI will result in what? So now let us write all these things. You will tell me all the advantages now. Advantage of AI. And I think in one of the class I have written this somewhere. Think and let me know fast, one by one. Everyone, start telling. Huh? Wait, one by one. Yes. First, we get first information. Okay. Quick information, right? Next.
Sir, increase the work efficiency.
1 minute. We can write quick and precise information we can get. Next.
Sir, increase the work efficiency.
Okay. Increases the work efficiency. This will come under this work efficiency only. Next. How it can be easily used.
Sir, reduce human error.
Okay. Easily accessible. Easily accessible means just you have to download, right? Accessible. Then what you told?
Sir, reduce human error.
Reduces human error. Next point. Done, done, done. Tell me fast. Online guys, you are setting like you can also search
Sir,
and let me
cost
know.
reduction.
Cost reduction. Okay.
Yes.
Fraud detection. Okay. Then network automation. Then
Sir, enhanced customer experience.
no. Example. Huh? That that is not the advantage. That is it is doing that work. Any other advantage that you wanted to write? Huh? Yes, anyone, please tell me. What about online guys? You're not telling any advantages. Tell me fast. One by one, tell. At least you can search on ChatGPT and tell. Okay, that is done. But any other thing that are the features.
Sir, better decision making from data analysis.
Okay, we can say hmm? Tell me fast.
Vishal,
Enough. We can write more. Yes, please.
can you hear me?
Yes, I
Okay.
can.
I'm seeing you since long. I think something wrong with my mic.
Yeah.
Okay.
You want to add any
Personalized
point?
customer service.
Personalized customer service. Ah, we can say.
Sir, enhanced customer experience, both are same, na?
Where we have written that.
Yeah, the personalized customer
Okay.
service enhances something similar only.
Right.
Sir, using chatbot, we can find easily.
Right. Then anything else? Only this much. Tell me disadvantages now.
Take jobs.
Lack of
Disadvantage.
knowledge.
First,
Self
I
knowledge is
would
not
like
there. Just you are doing all
lack of
AI knowledge.
no, lack of emotional intelligence. It says that it works like a human. Do it is it going to have any emotion come like how we had the human? Jobless. Huh? Job dislocation, right? Or what we can say? No, no. There should be certain good words. I wanted to write that. Huh? No, 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 no. I have C. Wait. Let me have it as somewhere. Just wait.
Job displacement concern.
Huh. Job displacement.
Sir, lack of transparency.
Hmm?
Lack of transparency.
Lack of transparency. Oh, you can say.
Yes.
And privacy concern.
Privacy concern is the major issue. One minute.
And over dependency.
See, in the case of advantage, you can add one more point. Enhanced decision making, because that is as it is going to compare all those things. That's why. Then we can say innovation. Adaptive learning. Hmm. Then in this, we have to write lack of this emotional intelligence, job displacement. Then we have to write privacy concern.
Over dependency also we can
Yeah,
write.
privacy concern. Then over dependency machines on the technology. Higher development cost. Development cost is there. And maintenance cost. That is only maintenance. This is only
Sir,
the screen.
lack of reliability.
We can say this one. And one more thing, it gives biased information. Biased and discriminating information, we can say.
And environmental impact.
How?
Training large AI models requires significantly, power, energy, and whereas it's saying like
Okay, we can have.
I am Googling how I know this.
I know that.
My Google is saying like that.
Uh, right?
Computational
Deep fake.
power and energy, which has a considerably environment footprint. Okay.
Deep fake is there, no?
Deep fake.
Separate. Ethical
Deep
concerns, we can say. Deep
fake.
fake or ethical concern.
security risks comes in this is something different, yeah. Security risk.
Okay, so like we got that these are the advantages and these are the disadvantages of the AI. So at one time it is useful also, and it has certain disadvantages also. So pros and cons we have everywhere. It depends how we are going to use that case, right? So based on that only we can control everything.
Did you write the high cost?
High cost, I'm not written.
Developing and
So we
implementing
can
AI
write
system
here one
can be
more
very
point.
expensive, requiring significant financial resource for research, development, and deployment. Huh. High cost we have.
High cost and deployment.
This word I like it. Lack of empathy, creativity.
Hmm. That's why I have written emotional intelligence and lack of creativity. Fine. Okay, so one last thing. Let me see. They have to take one router, come to this router, then come to CLI, give no, enable config space D, and give a host name. Let's say LAN router. Okay, I will give an enable password here. Admin 123. Give exit, give exit. No, and we will save this password, WR. If I will save this, then what will happen? If I will switch off the device, again switch on the device, it will ask me the password. Let's see that. Give exit, come to physical, zoom in, switch off. And now switch on. Come to CLI. Let's see what happens. Huh? Reload. When again it's to start. Reload the device. Well, no, after the start, we can say. We're not going to do power off and on that. Okay. See now, when we got, it is showing you as a LAN router. It means that here host name is present, everything is fine. Enable. I forgot the password. So we have to discuss how to recover the password. Okay. So now you have forgotten the password. So in that case, what you have to do, you have to come to physical of this device, on it, come to CLI. While it is booting, that time only control in Cisco packet tracer, you have to press Control C. In real devices, you have to press Control plus pause break. Pause break key will not be there in the laptop. It will be there in the keyboard. Okay. So you have to press what? Control plus pause break. Once you press that, you will come to this mode. Okay. 1 minute. Let me find one thing. I have done several research on this. But what I found that even though you will be giving all this command, it will not work. Okay, we'll come to that part. Just see. Now, So what I told you that you will be coming to this remote mode. Okay, so here you have to write config. Config, restart control config 2142. Config 2142, then reset. Why we give this command config 2142 to bypass NVRAM? Now what happened that when we given the command, so it was in the RAM, running command it will be in the RAM. When I saved, it is in the non-volatile random access memory NVRAM. Now in this case, as it is same and it is in the NVRAM, what if I bypass the NVRAM? If it will bypass NVRAM, it will not ask me the password, right? So for that, I have given command config 2142. Then what we have given reset. Enable config space T. Now nothing is present, right? So even if you give here exit and give command show run, nothing is present. I want to get all the information. So for that, what command I will give? Come to config space T, and then you give copy. I think in the enable mode only. Copy startup and running config. When I have copied startup and running configuration, now it is showing you what? LAN router. Then I'm in which mode? Enable mode only. If I'm in the enable mode, if it will not ask me any password. So I can see here what is the password. Show run. Admin 123. I have seen the password, right? If you want, you can change also. You can modify also. Otherwise, you can put it same. Now what happened? No, every time, whenever you will try to log in, it will bypass NVIDIA. Now, as I have seen the password, I know the password. So why to bypass this NVIDIA? Again, I want to have the NVIDIA back, NVIDIA like steps back. So for that, we'll write here configure register 2102. Then you will write here do WR and do reload. Enable admin 123. Got the point? So first step, what we did. So password recovery. Now, first thing that you have to give enable password. Enable password. Then one password. We have given the password. We forgot the password. To recover, what is required? First, you will on and off the router. This can be done in the switch also. No problem. Or we can say device. After that, while device is booting, press Control plus pause break key. Control plus C in Cisco packet tracer. While device is booting, you will come to remote mode. In the remote mode, what we have to give? config 2142. This is used to bypass NVRAM. Then what will you give in the remote mode only? Reset. There is power cut. Please wait.